Here's integrated 3. It's problem 6-44. It says a survey of 80 seniors at Algiers High School finds that 65% have been accepted to a 4-year university. A computer simulation is conducted and the proportions sorted to determine the sample-to-sample variability. So I got a little bit confused for a minute because it said 80 seniors, but the actual simulation has 100. There's 100 data points here. So if you count all these numbers, there's 100 numbers here. Okay, and the mean is 0.65. So we are going to determine the upper and lower 5% bounds of the sample-to-sample variability. So the lower and upper 5% bounds. So there's 100 numbers. Like, you could do it like this if you wanted. If you didn't know, you can go 100 times 0.05. Wait, oops. I wrote divided by. And you could find out that it's 5 numbers. But what I usually do is I know that I'm looking for the middle 90% of the data, and so that I have to take 10% off. So I'm going to take 5% off the small numbers and 5% off the bigger numbers, like 5% off the beginning, the lowest numbers, and 5% off the biggest numbers. And I know that if there's 100 numbers, 5% is just 5 numbers. So that's how I'm doing that. And I'm finding the lower and upper bounds. So like the kind of cutoff point in between, see how there's like 1, 2, 3, 4, 5? The cutoff point is right in between 0.56 and 0.56, but really that's just 0.56. So that's our lower bound. And then the cutoff point, 1, 2, 3, 4, 5, here is 0.74. And then so I kind of wrote this out so it'd be a little easier to understand. Well, actually, first, I don't even want to do this yet because that is the answer that they want for letter A, is they want the 0.56 and the 0.74. Those are the lower bound, upper bound, okay? So letter B, predict the proportion of seniors who've been accepted to a 4-year university and give the margin of error. So I'm going to predict the proportion based on the mean, which was 0.65, remember? And then I'm going to say plus or minus the margin of error, but you don't know what the margin of error is yet. So to get the margin of error, you take half of the spread of the middle 90% of the data. It's kind of like when you have some kind of distribution and you want to take you want to get rid of those like really small and big numbers. You want the middle 90%, so that's why we have upper and lower bound. So the way you get half the spread of the middle 90% of the data is you go the upper bound minus the lower bound, and then half of it you divide by 2. That gives you margin of error. So our upper bound was 0.74. And our lower bound was 0.56, and you divide that by 2, and that actually comes out to be 0.09, so that's our margin of error. So as a percentage, I move the decimal two places to the right, so that's about 9%. So I'm going to say that my answer is 65, because of the 0.65. 65% of the students are going to get accepted, plus or minus 9%. So that could be whatever 65 minus 9 is, between, actually 65 minus 9, let's do it. So between 56% and 74%. So between 56 and 74% of the students are going to get, what was the thing again? have been accepted. Okay. And that's about, I think that answers it.